Okay, so today we're going to go over polynomial and rational functions, which is page 155 on your packet, 155 page. So first we're going to start with polynomial functions. So polynomial function, it's a smooth graph, which is going up and down, depends what is the exponent. So polynomial, pretty much polynomial means you have many terms. Poly means a lot terms. So the polynomial looks like, I'm just going to give you an example, like 3x to the 5 minus 2x cubed plus x squared minus x. It could be something like that, plus 7, for example. So this function here is an example of polynomial function, which have x with exponents, and it can be higher exponent, and the numbers in front of coefficients, which are, they have to be real numbers. So the exponents for x have to be natural number, like 1, 2, 3, 4, and so on. Okay. So what you're going to do, we're going to look at the graph. The highest exponent, the highest exponent for x is called the degree of the polynomial. So in this example, the degree is 5. And depends what is the highest exponent. That tells you how the graph looks like and how many x-intercept you have. So the highest exponent is the degree. And the degree tells you how many solutions you're going to have, how many x-intercepts you're going to have. So if the exponent is 5, if the highest exponent is 5, if the degree is 5, you're going to have 5 intercepts, 5 x-intercepts, and you're going to have 4 turning points. Turning points on the graph are points like this. If you look at this graph, you have one turning point, another turning point. And these are the x-intercepts. So the x-intercepts are the place where you cross the x-axis, okay? So always the turning points are one number less than the degree of the polynomial, okay? Everybody understand that? Okay, so now we're gonna have examples here. They're gonna give us a graph, and we need to figure it out how many, we're gonna answer the questions, how many intercepts, how many, like how the graph looks like. So let's start with number 1. So in number 1, we have, the first question is, this is the parabola, right? We know it's a quadratic function, and you have how many x-intercepts? You have one here and one here, right? So there are two x-intercepts. List the x-intercept. What are the x-intercept? -2 and 0 is the first point, and the other one is going to be +2 and 0. The x-intercept always points on the x-axis, and the second coordinate for that point are going to be always 0. Okay. Now let's look at number. We have one more. Does the graph cross or bounce off the x-axis at each x-intercept? What that means? So crossing the x-axis means you're just gonna go through the x-axis. You're crossing it. Bounce means if I have a graph coming like this and it's going up again. So this is how you bounce. You just touch the x-axis and go up again. Okay, so that's right. Somebody answered this question. It crosses the x-axis. So here you're just gonna put, does the graph bounce, or we're gonna write cross. Okay, that's right. So now let's look at the number 2. Number 2, we have graph, and you have how many x-intercept? There are 3 shown, right? That's correct. One of them is here, another one is here, and we have one more over here. So there are 3 x-intercept, and let's list them. So we have -3 and 0. -1 and 0 is the second one. And the other one is 2 and 0. So these are the x-intercepts. And the next question is it cross or bounce? What's happened here? We also cross the x-axis, yes? Okay, so that's the first 2 questions. Let's go over the next 2 questions. We have number 3, how many x-intercepts are showing? We have only one x-intercept, right? So the highest degree, the degree of the polynomial, shows you the maximum number of x-intercepts. So here we have only one, and the graph is a parabola. So this is quadratic function. but you're crossing the x-axis only at one x-intercept. So it's only one x-intercept, and that intercept is -4 and 0. That's the coordinates. That's the coordinate of that point. Now, is it cross or bounce? So this is the example where the graph bounce. That's correct. Yes, it's gonna bounce. Good job. It's gonna bounce because it's touching it and it's going up again. Now the next one, number 4, we have how many x-intercept? We're not crossing the x-axis, so they're gonna be 0. List them. I'm gonna put none. There are no x-intercept. You're not crossing the x-axis. See, we still have parabola. It's a quadratic, but in this case, the quadratic equation have no real solutions, because the real solutions are the one where you cross or touch the x-axis. In this case, you're just bound. You're not touching at all. You're not bouncing. You're not touching the x-axis at all. So you have no x-intercept, which means the cross or bounce, I'm gonna put none also. You're not touching, you're not crossing. In this case, the quadratic equation have imaginary solution. I'm gonna put here imaginary solutions, and that's what I'm gonna write. Imaginary solution. The quadratic equation have imaginary solution. Okay, everybody understand that? Okay, so then we're going to go to the next one. We're going to solve equations by factoring. I'm not going to go over that. We did a lot of solving by factoring. We have the test over this. Now let's go over 6. Here we have to work backwards, and I think you have this also on the test. They give me the solutions, -2 and 9, and you have to find the factor form. So the factor form is going to be opposite of the -2. You're going to put x next to it, and it's going to turn to x plus 2. And the other factor from 9, you're going to get x minus 9. And then when you factor, you're going to get the quadratic equation. So you're going to, when you FOIL, you multiply. X times x is x squared. X times -9 is -9x. 2 times x is plus 2x, minus 18 equals 0. So this is the quadratic equation. We just have to combine the x's. So the actual quadratic equation here in factor, they want the factor form actually. So this is your answer here, just the factor form. Okay, you don't need to FOIL, but if you need to get the quadratic function, you actually have to FOIL, but they don't ask for that. They just want the quadratic equation in factor form. Okay, so that's how you do that. And then they ask me to do some more of those. So let's do 1 or 2 of those. So let's do number 8. So number 8, x is equal 0. So it's going to be x minus 0 is x, positive, negative is just x. And then from 5, I'm going to get x minus 5, always opposite sign. So this is my factor form of the quadratic equation. Now, the parentheses in front here by x, you don't need to put them. You can just put x in front, and then x minus 5 is the second factor. So that's how you write this. Let's go ahead and do one with fraction. So let's go ahead and do, you can do, which one you want me to do? Let's do, somebody said 12. Okay, let's do 12. So from -4, I'm going to get x plus 4. It's a opposite. And then from 3/5, I'm going to get x minus 3/5 equals 0. Okay, now you can leave it like that if you like, or you can just move the 5. Remember how you did the shortcut method, factoring by shortcut method? You can move this 5 in front of the x. So it's going to look like x plus 4 times 5x minus 3 equals 0. Either one is okay. Okay, so that's how you factor, how you get the factor form with the given zeros. So give me the solutions, you're going to get the answers. And we did something like that before. Okay, so let's look at the graph of the polynomial function. The graph of polynomial function is a graph which is smooth curve up and down, like going up and down, crossing the x-axis or bounces the x-axis. And the question they're asking is how many real roots, how many x-intercepts technically they're asking. So if let's look at number 1 and 2, I'm going to do only 1 and 2. and you can do the rest in groups. So number 1 and number 2, how many real roots we have? Real roots means how many x-intercepts. So looking at number 1, how many you have? 1, 2, 3. There are 3 real roots. Real roots is the same like x-intercepts. What is the minimum possible degree of the polynomial if it has only the real roots shown? So what is the degree? So the degree of the polynomial, this is 3. Somebody said 3. Yes, let me explain though. Let me explain. So the degree is 3 if you cross in the x-axis. Okay. So whatever you cross the x-axis is going to be, you count for 1. If you bounce the x-axis, like here we're bouncing, this is going to count for 2. So this point here at 1, because at 1 you're bouncing the x-axis, this is going to count for 2. So you have 1 degree, 2, 3, 4. So the degree is going to be 4. Everybody understand that? So if you cross in the x-axis, you have 1 factor. If you bounce the x-axis, that means you have square. The factor is squared. So if in the actual equation, you don't have, so let's just go back to the factors. Let's do the factors and you'll see how you get that. So wherever you bounce the x-axis, that means you have square. So you're crossing the x-axis at 0, right? So this is 0, 1, and 2. You're crossing the x-axis at 2. That means x equals 2. I'm sorry, x equals 1. Also, your bounce at 1, that means you have x equals 1. But this is multiple solution. That means you have another one, x equals 1. These are always in pair. So if you bounce, it's always in pair. And then you have another one, which is x equals 2. So these are the x-intercept. These are the actual solution of the quadratic equation. So if I have 4 solutions, there are 3 real roots, but one of them it's bouncing, it's square, it's a double, okay? So they're gonna be, the degree of the polynomial is gonna be what? It's gonna be 4, okay? So the degree of the polynomial is gonna be 4, because one of those degree is double, okay? Write the possible equation in factor form. Okay, so the possible equation you're going to get from the zeros. I'm sorry, here I put 1 instead of 0, right? This should be 0. Okay, so let's write the possible equation. So it's going to be x equals 0 is going to give me, I'm going to write the answer here, down here. So the possible equation is going to be x from 0, you're going to get x. Then you're going to have x minus 1. And those are 2 of those, I'm going to put square. Always, if you bounce, have to be square, have to be 2. And then from the 2, from this number, I'm going to get x minus 2. So this is the factor form of that graph. Everybody understand how we're doing it? Any questions? So remember, if you bounce, they're going to be 2. They're going to be square. Okay?
And would it always be minus?
It's always opposite of the number. So if the x equals -5, it's going to be x plus 5. It's exactly what, yeah, thank you for asking that. It's exactly what we did here. So you have x equals -4. See the one we just did here. -4, that gives me x plus 4. This is positive 3/5. This is negative 3/5. It's always opposite. If x is equals number, the factor is going to be x with opposite sign. Got it?
Okay, got it. Thank you.
Okay, thank you for asking that. Yes. Okay, so that's how you do number 1. Let's do number 2. So on number 2, we have, let's see how many, we don't have bounds here, right? Everything is cross, 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 right? So they're going to be 4 real roots because you're crossing 4 times. 4 real roots. You're crossing everywhere, and let's write them out. So what are the solutions? X equals 1, x equals 2, x equals 3, and x equals 4. It's crossing all these numbers, right? And you're crossing, you're not bouncing. So let's write the equation of the graph of this function. So the equation is going to be what? From 1, what you're going to get? X minus 1, right? Opposite. The other one is 2, so it's going to be x minus 2. The next one is 3, so it's going to be x minus 3. And the last one is x minus 4. And none of those have square because it's everywhere crossing. Okay? So this is my function. This is how
I have a question.
Yes.
For the degree,
Yes.
do we have to write out each
Yes.
one instead of just putting like the number?
Yes, yeah, I forgot that. Yes, you have to write the degree. Thank you. So the degree, what is the degree here?
It's going to be 4.
That's right. Good job. The
But can
degree.
we just put degree equals 4? Do we have to write out x equals 1, x equals 2?
These are different things they're asking. See, they're asking, that's what they're asking. Find the real roots, how many x-intercept, write the degree. You have to write the degree. What is the degree? And also they're asking to factor form.
Okay.
Okay. I mean, writing x equals all this helped me to get the factor form. Okay.
Okay.
Got it? Okay.
Got it.
Do you want to do another one or everybody okay with that? You guys okay with this? Okay. You're going to have a chance to practice in groups. Okay, so let's go ahead and do the next one. So rational function. A rational function, it's a fraction, right? So talking about fractions here, determine wherever the fraction is 0, it's undefined. How you know that? Always if you have 0 in the bottom, it's undefined. So this is undefined. If 0 is in the top, the answer is going to be 0. Okay? How about number 3? What is it? Is it 0 or undefined? Number 3.
Undefined.
Undefined, good job, because 6 minus 6 is going to be 0. So this is undefined. And how about 4? It's going to be 0, yes. Because negative 4 plus 4 is 0 in the top. If the 0 is in the top, it's okay, it's 0. Okay? Now, the next one we need to do is decide if the equation is linear or quadratic, then find all value of x which make it true. So that means solve it, right? So the first one, x minus 7, is it real? I'm sorry, is it linear or quadratic? Linear is with exponent 1, quadratic has exponent 2. So what is it?
Linear.
Linear, that's right. So all of these 5, 6, 7, 8, they're linear. And the rest of them down here, they're quadratic, right? So all these are x square, x square, x square. So these are quadratic. Okay, so these are gonna be quadratic. Okay, and I'm gonna solve just 1 or 2 of those because you already know how to solve this. I don't know why I need to do that, but probably just kind of review. So which one you want me to do for 5, 6, 7, 8? Let's do one of those. 5, 6, 7, 8. Pick one. We have 8. Thank you. So how you doing 8? We're going to get x by itself. In order to get x by itself, you have to move all the numbers in the other side. All the x stays in the same side. So I need to move the 7 over. So I'm going to add 7 in both sides. And that will get me, this cancel, 7 minus 7 is 0. I have negative 4x equals 0 plus 7 is 7. And then the last step is when you get x's in one side, numbers in the other side, you're going to divide by the same number in front of x, because negative 4 divided by negative 4 is 1x. That's what you want to get. X equals, and 7 over 4, you can reduce it, so just write it negative 7 over 4. And that's my solution. Okay? So you do the same way all of those linear equations. Now the quadratic equations, let's pick one of those also. You can solve it with factoring, or you can solve it with quadratic formula, and you know all these methods, right? So let's just do one of those for practice. Which one you want me to do? Number. Okay, it's okay, Alexis. So which one? Let's do number, which one? 11, 10, or 9? Somebody say 11. Okay, let's do 11. So number 11, we're gonna factor it. So let's factor it. So in front of x is 2, x squared is 2. And so that means you're gonna do AC method. So we're gonna multiply 2 times negative 21 is gonna be negative 42. Now we're gonna find 2 factors of 42 which add up to 11. So it's a negative. So let's see, let's list the factors. 42 is 1 times 42, 2 times 21. You can divide by 3 also. What is 3 times? What is that?
14.
I'm sorry? 40, right? Okay, that's right. And then actually, I think these are the numbers because one of those have to be negative to get negative. So these are the numbers we have. Okay. You got it? So these are the 2 numbers I'm going to use to factor it. So using those two numbers, I'm going to do, I'm going to put x minus 3 and x plus 14, and I'm going to divide those numbers by 2 because we multiply by the first number. So it's going to be x plus 14 and divide by 2 equals 0. Now here I can reduce this, or I can just solve this equals 0 and this equals 0, and you're going to get x equals 3 over 2, opposite of it. And then the other one is going to be 14 divided by 2, 7. So when you move it over, it's going to be x equals negative 7. So these are my 2 answers, right? You know how to solve quadratic, right? Just a review of it. Okay, any questions on this? Okay, so we're going to go to the next one where we're going to find, we're going to graph linear and rational functions. Okay, so let's start with this. I'm just going to do one question of this because this graph in a linear function, it's easy. So if the the function is equal, the graph is x equals 2, that's the equation. And x equals 2 is going to give me, what's going to give me, what is the slope? If x is equal to a number, the slope is going to be undefined. Remember that, right? It's a vertical line, undefined. The x-intercepts are going to be x equals 2, right? And the y-intercepts, there's no y-intercept because the graph is going to be, see, x equals 2, the graph looks like this, like that, right? And you have no x-intercepts. No y-intercept, sorry. The x-intercept is 2, okay? Everybody understand that? So this is how you do it. You graph it, looks like this. The slope is undefined. The x-intercept is where you cross the x-axis. The y-intercept, you don't cross the x-axis because the graph is parallel to the y-axis. Then looking at the next one, let's do 13 also. Y equals negative 3. The graph is going to be like this. It's a horizontal line going through negative 3. And what is the slope? The slope is going to be 0. X-intercept, no x-intercept because you don't, it's a parallel to the x-axis, and the y-intercept is going to be negative 3. Okay, if you want to write the point, it's going to be 0, negative 3. Okay, and let's put the x-intercept also here with coordinates. So it's going to be 2, 0. Okay, so this is how you solve this. I mean, we did this before, so it should be something like a review, right? Everybody remember that? Yes? Any questions? I'm gonna write 0 here. The slope is 0. Okay, any questions here? Okay, number 14. They're asking which of those define vertical line. So vertical line, how the vertical line looks like. You see that? Vertical line looks like what? X equals number, right? So if it's X equals number, it's gonna be a vertical line. So let's just circle them. So if the equation have only X, so vertical line have only, I'm gonna spell only X in the equation. So there is no Y in the equation. It's going to be X in the equation. So A is vertical. This is also vertical because there's no Y. This one also is going to be vertical. See, there's no Y in that equation. How about F or G or H or I or J? Which one is a vertical also? I, that's right, I and J. Good job. Okay, so these are the vertical lines. You have only X equals number. Okay, so rational function. We're going to start with the graph of 1 over X, which is the easiest one. 1 over X. 1 over X, pretty much you divide it. 1 divided by 1. And here we have to peel out this table to see how it is. According to the table, what happens to input if to the output if the input gets smaller? Okay, so here we're going to talk about we're going to talk about infinity pretty much. So let's go over this first. So the function is 1 over X. So when X is 1, 1 over 1 is 1, right? Now when X is 0.1, 1 divided by 0.1 is going to be 10. 1 divided by 0.01 is going to be 100. And then you're going to have 1,000. And then you're going to have 10,000. And then 1 with 5 zeros, 100,000. And then 1 with 6 zeros, it's a million, right? Okay, now, so this is what's happened. So that's the question they're asking. According to the table, what happened to the output, which is fx, when the input gets smaller, approaching 0? So when x goes to 0, this is the symbol using approaching 0, going smaller and smaller, 0.0001. What's happened with f of x? The function goes to a huge number, right? 1 million, which is, we're using the symbol infinity. Okay? So if the number is getting small, bigger and bigger, it's going to go to infinity. Okay? That's the symbol we're using. And then if the next question is, we're going to fill out the rest of the table. So if the numbers, if the x gets larger approaching infinity, so you're going to write when x goes to infinity. What's happened with the function? Let's see what's happened. Let's fill out the function and let's see where the function is going to. So you have, again, you're going to put 1 over 1 is 1. 1 over 10 is 0.1. 1 over 100 is going to be 0.01. 1 over 1,000 is going to be 0.001. And then you're going to have more zeros included, right? And another one, 3 zeros. And here you're going to have more zeros, right? Actually, 4 zeros here, right? And then you have 1, 2, 3, 4, 5, and 1. Okay, so that's how you do it. Now, what's happened with the numbers? When x go to infinity, to bigger numbers, what's happened with this number? They're going close to 0, right? They're getting smaller and smaller. So that's going to happen with the graph also. So let me show you how the graph looks like. So the graph is going to look something like this. 1 over x. And this is for positive x. If the x's are negative, it's going to look something like this. So you have two parts of the graph, one in the left side and one on the right side. And you can do the left side here below the x-axis the same way with the table we did. But I'm just showing you how the graph looks like. See what's happened when the graph is going close to 0, close to the x-axis. See when the graph, the x is going close to 0, the graph is going to infinity. This is what they're saying. See, x is going close to 0. You're going close to 0 here. The graph is going to infinity, right? And then when the function is going, when the graph is going to, let's use this color. So when the graph, see, the function is going close to the 0, going to infinity, going to a big number, is going, the value is going close to 0. Okay, so this is how the graph looks like. Everybody understand that? So this is the graph of 1 over x. Okay, so all the rational function, the fractions, they're going to have a line like this, which is called vertical asymptote. So the x-axis, the y-axis here, it's an axis. So this is called vertical asymptote. It's an axis, it's a line, vertical line, where the graph is going very close to, it's going close to that line, but you never cross it. And also the x-axis in this case, it's called horizontal asymptote. And the horizontal asymptote, it's a line, horizontal line, where the graph is going close to, but you never cross it. So remember when you do the, what is called when you do the graph, when you graph it, when you graph a rational function, the graph always going to have vertical asymptotes and sometimes horizontal asymptotes. Okay, so that's how the graph looks like. And then we're gonna see what else we have. We have to find the vertical asymptote, the domain of the functions, and we're gonna also talk about domain and vertical asymptotes. Everybody understand?
To the rational functions, please, like the chart.
Vertical asymptotes and the domain. You're gonna find that in a second. Yes. Yes. Let me here. The graph.
No, up at the table.
Okay.
There you go. Thank you.
Mm-hmm. Okay. Got it? Okay. Okay. So let's do this now. I'm gonna, okay. So here we have to find the vertical asymptote and you have to find the domain of the rational function. Now, the domain of polynomial function, it's all real numbers from negative infinity to infinity. The domain for rational function has restrictions, and the restrictions for that comes from the denominator, because the denominator, remember, divided by 0 is what? Undefined, right? So that's where the restrictions come from. So when I find the domain, I'm going to start with number 1. For domain, I'm going to write it here. You're going to take the bottom of the fraction only, which is x minus 6, and you're going to solve it not equal 0. Okay? And how you solve it? You're solving it. You're adding 6 in both sides, right? So you're going to get the domain is x not equal 6. Now, one way to write the domain is if you write with set builder notation, so write x like this, where x is not equal 6. This is called set builder notation. Okay, that's the domain. That means the function is gonna have graph everywhere but at 6, because when x is 6, you're gonna get undefined value. So you don't have function there, you don't have point there. The graph doesn't go to 6. When x is 6, there is no graph. And that's exactly the place where you have a vertical asymptote. So the vertical asymptote is going to be the same, but instead of not equal, it's going to be x equals 6. And remember, the x equals 6 is the graph of vertical line, right? So the vertical line is your vertical asymptote. So let's go back to the graph we have here. So look at this vertical asymptote. The vertical asymptote, what is the equation? The y-axis, right? So the equation here is what? X equals 0, right? That's the vertical asymptote. Now let's look at the equation. Vertical asymptote is x equals 0. Let's look at the equation. What was the equation of the function? 1 over x, right? So let me write it here so I can see it together. F of x, the function is 1 over x. See, the bottom is equal 0, give you the vertical asymptote. Everybody see that? And when x is 0, you don't have graph because the graph is going exactly at 0, you don't have graph because the graph is going close to 0, but you never cross it. You never get x equals 0. Make sense? Everybody understand that? So for rational function, you have vertical asymptotes in the places where the domain is undefined. Make sense? So when you find the vertical asymptote and when you find the domain, you're just working with the bottoms and you solve it equals 0. So domain is not equal 0. The vertical asymptote is equal 0. That's the difference. You got it? Everybody, that's easy, right? Yes, let's do one more. Pick one. 2, 4, or 3. 2, 3, or 4. Which one you want me to do? So here we're solving linear and quadratic equations because that's what you have in the bottom of the fractions. Which one you want me to do? 2, 3, or 4? Somebody says 2, somebody said 3. So let's do both. Okay, so for number 2, again, I'm going to work only with the denominator. So I'm going to solve x squared minus 6x minus 16 equals 0. So how you solve that? 16, what times what is 16? 8 and 6, right? So it's going to be 2 and 8. 2 times 8 is 16. Let's see. X and let's see which one is plus, which one is minus. 2 times 8 is 16, negative. So this is negative because it has to be negative 6. Like that, right? Negative 16 is 2 times negative 8 is negative 16. And 2 minus 8 is negative 6, right? So this is how you factor it. And then you solve this equals 0, it's going to give me negative 2. And when I solve this 0, it's going to give me positive 8. So now let's write the domain. So the domain is going to be all x's where x not equal negative 2, comma 8. So they're going to be 2 vertical asymptotes, right? Because you have 2 restrictions here. The graph is not going through negative 2, the graph is not going through 8. So I'm going to write the vertical asymptotes are going to be x equals negative 2 and x equals 8. Got it? Any questions? Okay, let's do 3. So for number 3, we're going to work with the bottom again. So we're solving x squared minus 4 equals 0. We can, let's solve square root property. I'm gonna add 4 in both sides and I'm gonna take square root. So I have x squared equals 4 and that gives me x equals 2 and negative 2, right? Plus or minus 2. Because square root of 2 is 2, 2 times 2 is 4, and also negative 2 times negative 2 is also 4. So that's why you have positive or negative 2. So we're going to write the domain. It's going to be x, where x is not equal plus minus 2. And the vertical asymptotes, they're going to be 2 vertical asymptotes again, are going to be x equals 2 and x equals negative 2. Okay, everybody understand that? And for number 4, of course, you can factor it. I'm just going to solve it real quick. So I'm going to factor x, and you have x, 8 minus x. And this give me x equals 0. and this will give me 8. Okay? When you solve 8 minus x equals 0, you're going to add x in both sides, and you're going to get x equals 8. Okay? And just write the domain is not equal 0 and 8. The vertical asymptote x equals 0, x equals 8. Okay? Everybody understand that? So it's really easy to find the vertical asymptote in the domain. You just do the same thing, just one of those is not equal, the other one is equal. Okay. Next one, it says write the equation of rational function that satisfy the following requirements. So they give me the vertical asymptote, and you just have to make up function. And how you do that? If the vertical asymptote is at x equals 10, that means in the bottom of my fraction, I'm going to have something which is going to have solution x equals 10. So this is how you're going to write it. F of x equals. Now in the top, you can put whatever you want to put. In the bottom is going to be x minus 10, opposite of 10. Okay? And what you can put in the top, you can put whatever you want. I'm going to put like x squared plus 3, whatever you want, doesn't matter. Okay? Got it? That's one example. Okay? Let's do the next one. We have two vertical asymptotes. So what that means, my function is going to look like what? Something on the top, doesn't matter what. And in the bottom, I'm going to have what? What are the factors? X from -5, what is going to be the factor? Plus, that's right, plus 5, good job. And then from 2, I'm going to get x minus 2. And you can leave it like that. And you can put whatever you want in the top. I'm going to put just 1. 1 over this. Okay? Doesn't matter what you have in the top. The top doesn't matter. If the asymptotes are given, the bottom is going to look like that. And the top could be anything. Okay? Now, the next one, number 7, we have to find the domain is given here. So if x is not equal plus or minus 5, that means the bottom is going to be x plus 5 and x minus 5, right? Or that means you're going to have vertical asymptote x equals 5, x equals -5. So I'm going to write the function f of x equals, and here you can put whatever you want in the top. I'm going to put 13. I'm just picking a number. And then in the bottom, you're going to write x minus 5 and x plus 5. And you can just leave it like that. Okay, that's it. Any questions on this? Okay, the next one is we have to solve few applications here. So we have a word problems where they're talking, we have a rational functions, obviously, some of those, and we have to think about what the denominator equals 0 means. So let's go over that. So let's start with number 8 and number 9 are the same. So which one you want me to do? 8 or 9? And number 10, it's a little different. So I'm going to do 8, 9, one of those, and 10. Which one? Nine. Okay, let's do 9. Okay, so we're going to do number 9 and number 10. So number 9 says, it costs money to keep our lake at Northwest Vista clean, right? Say there are 2 tons of population in the lake and the cost, so the function C here represent the cost in hundreds of dollars of removing X tons of pollution. Oh, it's a pollution, not population. Pollution. So this is the function given. We have 70x over 2 minus x. Now, how much will it cost to remove half a ton of pollution? So x is the pollution, right? So what that means, if I want to find the cost, is C of half ton, so it's going to be 0.5, right? So what that means, I'm going to replace x with 0.5. So I'm going to have 70 times 0.5 over 2 minus 0.5. So what that gives me, I can simplify that. So what's happened? We have 70 times 5 is what? 35, right? 35. And here 2 minus 0.5 is going to be 1.5. So when I divide this by 1.5, it's going to be, oh, sorry, 35 divided by 1.5, right? 23.333. Or let's reduce it to the whole number. How many $100? Or let's write it like that. $23.33, right? It doesn't say how to round, so I'm just gonna put it like that. 23. I'm just gonna keep it to the nearest cents. So 23,100. Hold on, 20. Sorry, hold on. Let me write it. 2300. 0.33 cents. That's how you round it, right? 2300 means 2,300, right? Everybody understand that? Yes? Now, the next one is explain what happens if Northwest Vista attempts to remove all the 2 tons of pollution. So we're going to try to see what is C of 2, right? I'm going to put 2 in the function, and I'm going to get 70 times 2 divided by 2 minus 2. So what I'm going to get? 140 divided by 0. What that means? This is undefined, right? It's undefined. Now think about what undefined means in this case. How much is going to cost you? What that means, you can clean all the 2 tons of pollution, or how much is going to cost you? What that means? Any ideas?
The cost of removing 2 tons of pollution would be infinite.
Good job. That's good job. That's right. Yes. So it's going to be infinity. You don't have enough money to clean that. It's impossible, right?
Mhm.
Everybody understand that? Good job. Good job. You got it right the first time. Good job. Okay, let's look at number 10. A typical round of golf is 18 holes where your cumulative score for the round is the sum of all shots you took on each hole. For example, if you took 4 shots on each hole, your score is 4 times 18 is 72. Okay, describe the relationship between the rounds of play and the score on 18 holes. So this is given here, the function. So when the scores are going, X goes bigger. So this is the graph, and they're asking which scores are impossible and why. So what do you think? What do you think? Which are impossible? So this is what you have, 72. So it's 4. 1.
So the more rounds you play, the lower your score.
Mm-hmm. Yeah. Yeah, looks like that. Okay. Pretty much, yeah, the graph is going close to the 18. That's your vertical asymptote. And is going to infinity. The score is going to infinity pretty much. Okay?
Okay.
That's right. Okay. So that's the last one. And then you have your homework. So any questions? Any questions? So that's what you have for polynomial and rational function.